Hello, welcome back to Learn Physics. In today's video, we are going to continue with our current electricity chapter, and in last class we learned about the EMF and internal resistance and potential difference. Yesterday I gave you one concept checking question, that is, a uniform wire of resistance 12 ohm is cut into 3 pieces in the ratio 1:2:3 and 3 pieces are connected to form a triangle. A cell of EMF 8 volt and internal resistance 1 ohm is connected across the highest of 3 resistors. Calculate the current through each part of the circuit. Okay, so here in the question, a 12 ohm wire is cut, dividing it into in the ratio 1:2:3. Okay, a cell of EMF 8 volt and internal resistance 1 ohm is connected across the highest value of the 3 resistors. Calculate the current through each part. We need to find out the current. Okay, how we can find out the current through the each part? We know, see, I is equal to E divided by capital R plus small r. Okay, for that we need the external resistors. So this 12 ohm resistor is dividing it into in the ratio 1:2:3. Okay, so here how we will be finding out the resistance of each part. See, total each one 6/1, 2/6 and 3/6. These are the ratio, right? So here for the first one it is 1/6 into 12, and the second one 2/6 into 12, and third one will be 3/6 into 12. Okay, clear? So this one we will get it as 2 ohm, and this one we will get it as 4 ohm, and this one we will get it as 6 ohm. So it's arranging is a triangular manner, right? So it will be arranging in a triangle. See here 6 ohm, and this one 2 ohm, and here it is 4 ohm. Now I arranged it in as a triangle, and this EMF it is connected with a cell which is having an EMF of 8 volt and internal resistance 1 ohm. Where it will be connected? It will be connected across the highest resistance. So it is, I am representing it like this. It's not mandatory you should represent like this itself. You can simply draw a cell, and there itself you can write down the internal resistance. That is not an issue. 8 volt and this is 1 ohm. Now we have the internal resistance with us. So how we will be finding out the external resistance? Capital R. Capital R, see, these two are in series, right? So 6 ohm and another 6 ohm is in parallel. So what will be the effective resistance? 1/6 into 6 divided by 12. So we will be getting it as 3 ohm. Now we can find out the current. I is equal to E divided by capital R plus small r is 1. E is 8 divided by 4. So we will be getting it as 2 ampere. We need to find out the current across each part. Right, each part of the circuit means here this is the first, here while current is coming like I equals 2 ampere is coming here, it will be dividing it into 2 parts, right? So one part of the current will be going across this one. So how much of current will be? See here one part, and here it is, here also 6 ohm. This is 6 ohm and this is 6 ohm. Then how the current will be dividing? Current will be dividing it into equal parts. Since the resistors are equal, current will be dividing it into equal parts. So how much of current will be flowing through each part? Here it is 1 ampere and here it is 1 ampere. So 1 ampere of current will be this passing through each section. Okay, clear? So in today we are going to study about the cells, grouping of cells. Already we learned about the grouping of resistors, right? So here we are going to study about grouping of cells, that is, if cells are connected in series and if they are connected in parallel, how this EMF and resistance, how it will be affected. Okay, so for that, first I am considering a cell here and this is another cell. This is point A, this point I am considering it as B, and this is C. Okay, this is the first cell which is having EMF E1, and this is the second one which is having EMF E2, and this is having this has a internal resistance of R1 and this has R2, and current is moving in this manner. Okay, for that, so if the cells are connected in series, which quantity will remain same? In series connection, current will remain the same and potential difference will be varying. Right? So first I am going to consider the potential difference between C and B. Okay, V, C, B. That one we are going to find out. Potential difference between C and B. So first I am considering this is C and this is B, and this is cell positive, negative. This is how current is moving. This is E2 and this is R2. Okay, so current will be moving from a higher potential level to lower potential level. Okay, so it is moving towards the lower potential, right? So starting from C, potential at C, higher to lower potential. That means potential is reducing. If it is potential is reducing, potential drop. So what will be the potential across R2? Minus IR2. Potential is dropping. Now coming to the cell, here it is negative, that is lower potential, and this is positive, so it is higher potential. So it will be potential is increasing. So I am writing it as plus E2 will be equal to VB. Okay, then tell me what is VB minus VC will be equal to E2 minus IR2. This is for VCB. Now I am considering between B and A. Okay, between B and A, while I am considering here, this is B and this is A, and here this is the cell. Here it is E1 and here it is R1. Here it is moving in this manner. So starting from B, VB, so here current is moving from higher to lower potential. Potential is reducing, so IR1, while coming to a cell it will become positive because lower potential to higher potential. So it is plus E1 which is equal to VA. Now we can write it as VA minus VB will be equal to, what is that? E1 minus IR1. Okay, clear? So this is how the potential difference. What will be the total potential difference then? Total potential difference or between the terminals A and C. Okay, VAC will be equal to VA minus VB plus VB minus VC. Clear? Now what is VA minus VB? E1 minus IR1 plus E2 minus IR2. That is equal to E1 plus E2 minus I into R1 plus R2. Okay, so while we are see what is the final result, potential difference across AC, that is VA minus VC will be equal to E1 plus E2 minus IR into R1 plus R2. So while we are comparing with V is equal to E minus IR, right? So this circuit, if I am drawing like this, so this will be the effective EMF and effective resistances R, this will be C and this will be A. Okay, current is moving in such a manner. So what is the effective EMF over here? This is the effective EMF, that is equal to E1 plus E2. Okay, what is the effective resistance in series connection? We already know this effective resistance will be R1 plus R2. Okay, so this is, see, this is negative, positive, negative, positive. In this manner it is connected. Okay, so you tell me, if we are connecting like negative, positive and positive, negative. Okay, if it is connecting like that, or positive, that is two positive terminals or two negative terminals are connected together, how the current will be, what will be the difference? Okay, we will see that. So here one is positive, negative, next again negative and positive. This is C, this is B and this is A, and current is moving in this manner, R2, E1, R1. If this is so, tell me what is VBC potential difference between, that is, while we are finding out this one, VC, this is lower to higher potential, higher to lower potential, so it is minus I into R2. What is this? This is at a higher to lower potential, minus E2 equal to VB. Okay, what is VB minus VC then? It is equal to minus E2 minus IR2. Okay, tell me what will be for VA, that is VB minus IR1 plus E1. It is going to higher potential, will be equal to VA. So VA minus VB will be equal to E1 minus IR1. So while we are considering these two, what is the potential difference between VA and VC? VA minus VC, total potential difference while we are finding out, we can take it as E1 minus IR1 minus E2 minus IR2. That is E1 minus E2 in minus I into R1 plus R2. This is the difference which we are getting. See, if the two negative terminals are connected together, effective EMF will be E1 minus E2, and if the one positive and one negative together it is connected, then effective EMF will be E1 plus E2. This is the case of series connection. Clear? So next we are going to study about the parallel connection. Clear? So next is in parallel connection. Okay, two cells are connected in parallel. So this is one cell like this, positive, negative, and here again positive, negative, and this is the parallel connection. So this is C, this is B, and C, and this is B. Okay, current is moving in this manner. Here it is dividing. So this is I1 and this is I2. This is E1, R1, E2, R2. Okay, now we are say in parallel connection, potential difference will remain the same, but the current will be varying. Clear? So we can find out VBC through E1 R1 and through E2 R2 also we can find out. VBC, that is VB minus VC, will be equal to, through this one if I am finding out, E1 minus I1 R1, and VBC through E2 while I am finding out, that will be equal to E2 minus I2 R2. So from here, from these two equations, we can find out the I1 value and I2 value. So here V equals E1 minus I1 R1. That therefore I1 R1 equals E1 minus V, and I1 equals E1 minus V divided by R1. So same way I2 we will get it as V equals E2 minus I2 R2, and I2 R2 equals E2 minus V. Therefore I2 equals E2 minus V divided by R2. Total current in the circuit I equals I1 plus I2. Therefore, E1 minus V by R1 plus E2 minus V by R2. Okay, clear? So, we can write it as E1 by R1 plus E2 by R2 minus V into 1 by R1 plus 1 by R2. Okay, so here we can write it as this one. What is the this while we are solving this one, R1 R2 is the LCM. So E1 R2 plus E2 R1 minus V into 1 by R1 plus 1 by R2. Okay, clear? So this is, from this we can identify what will be the effective EMF over here. E1 R2 plus E2 R1 divided by R1 R2, and effective resistance will be 1 by R1 plus 1 by R2. Okay, clear? So this is how we will be finding out the effective EMF in the case of parallel connection. Okay, so in parallel connection, the same rule, current will be dividing, so we are finding out the current in both the cases. But in the series connection, potential difference will be varying, so there we will be finding out the potential difference in each resistor, each cells. Clear? So next one numerical we will do. Okay, two cells E1 and E2 in the circuit shown in figure have EMFs of 5 volt and 9 volt and internal resistance of 0.3 ohm and 1.2 ohm respectively. Calculate the value of current flowing through the resistance of 3 ohm. Okay, the diagram is given like so. This is negative, positive, and this is positive, negative, and here it is 4.5, and this is a parallel connection here. Okay, here it is 5 volt, 0.3 ohm, and this is 9 volt, 1.2 ohm, and here it is 4.5 ohm, and here it is 6 ohm and 3 ohm. Calculate the value of current flowing through. Calculate the value of current flowing through the resistance of 3 ohm. We need to find out the current flowing through this one. Okay, so how we can find out? See here, EMF is given in both the cases. Suppose this is E1 and this is E2. What will be the effective EMF over there? E2 minus E1. Effective EMF will be 4 volt. Right? So how we can find out the total current in the circuit? We can find out, right? So how we can find out the total current in the circuit? So for that we need the total resistance. Total resistance R equals, see, 3 ohm, 1.2 ohm, 4.5 ohm. These are in series. These two are in parallel. These two parallel connection which we are getting over here, that will be in series with 4.5, 0.3 and 1.2 ohm. So here we can write 4.5 plus 0.3 plus 1.2 plus. So what will be the effective resistance over there? 6 into 3 divided by 6 plus 3. Okay. So here we will get it as 4.5 plus 1.5 plus 6 into 3 divided by 9. So this one 3 and 2. So here we will get it as 6 plus 2, 8 ohm. So here effective resistance we got it as 8 ohm. Then what will be the current? I is equal to V by R. Here 4 divided by 8. So we got it as 1.2 ampere. Now we need to find out the current across this one. Okay, current across 3 ohm. How we can find out the current across 3 ohm? Current across 3 ohm will be equal to V potential difference across 3 ohm divided by 3. Okay, for that first we need the potential difference across 3 ohm. So the total current across this 6 ohm and 3 ohm is, the current across this one we got it as 0.5, right? This is the 0.5 is the current. Then what will be the potential difference across it? 0.5 into V equals 0.5 into 2, that is equal to 1 volt. Okay, potential difference is 1 volt, therefore current will be 1 by 3 into 1, that is equal to 1 by 3 volt. Clear? So this is how we will be finding out the current across 3 ohm resistor. For that, first you need to find out the total current. If you are getting the total current, for finding out the potential, the current through 3 ohm, we need the potential across 3 ohm divided by 3, V by R. For finding out the potential difference, first we found out the current. What is the current across this one? We got it as 1.2. Okay, so I'll give you one question, that also one more question, that one you can do it as, you can try to do it as a homework. Okay, a student connects a cell of EMF E2 and internal resistance R2 with a cell of EMF E1 and internal resistance R1 such that their combination has a net internal resistance less than R1. This combination is then connected across a resistance capital R. Draw a circuit of the setup and obtain an expression for the current flowing through the resistance capital R. Okay, this one you try it. This is also a previous year question only. You try to solve it. If you are not getting, tomorrow I'll explain. Okay, so that's all for today, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.